We're going to take a look at reciprocal of sine, which is cosecant. All right, so reciprocal of sine cosecant. And how do I write that? Well, cosecant is equal to 1 over sine. Cosecant is equal to 1 over sine. This is a listening check. We'll go ahead and shade in reciprocals of sine, the title. So we're going to use a unit circle to fill in everything we know. So sine, remember, is the y. So sine of 0 is 0. And you take the reciprocal of 0, you're going to get 0 over 0, which is undefined because you cannot divide anything by 0. Then move on to pi over 6. So find pi over 6 right there. Sine is the y value. Go ahead and flip that. So it's going to be 2 over 1, which is going to equal 2. Then go to pi over 2. Go to the y value, which is 1. Go to take the reciprocal of that, which is flip that. 1 divided by 1 is 1. Go to the next one, which is 1 over 2. Flip it. It's going to be 2 over 1, which simplifies to 2. Go to pi. The y value is 0. Again, that's going to be another undefined one. All right, go to the next value, 7 pi over 6. The y value for that is that. Flip it. So you're going to get 2 divided by negative 1, which is negative 2. Go to 3 pi over 2. Flip that. You're going to get negative 1. Go to 11 pi over 6. Flip that. You're going to get 2 divided by negative 1, which is negative 2. Then go to 2 pi and you have 0 again, so 0 is undefined. All right, so going through the questions, what values of the graph will give you vertical isotopes? Well, it's whenever anything is undefined. So when is it undefined? So it's undefined at 0, it's undefined at pi, it's undefined at 2 pi. Okay, then you're not going to need to answer the question, are you able to list all of them? Why not? No, as it goes on forever. This is a listening check, coloring the word no. Okay, next question. What values are they equal to sine? So it's equal at pi over 2 at 1, because that's equal to 1 right there. It's also equal at 3 pi over 2, because it's equal to negative 1. Okay. And really what it is this. Why does this happen? When you take the reciprocal of 1 or negative 1, you're going to get the same thing. When you take the reciprocal of 1 or negative 1, you're going to get the same thing. Sketch a cosecant graph in the same axis as sine. Be sure to include any relevant isotopes. So let's go ahead and put our isotopes in. According to question 1, it happens at 0, at pi, and at 2 pi. So vertical lines are isotopes. Okay, then let's go ahead and sketch the values we know. They're equal to sine at pi over 2 and 3 pi over 2. So even though it's not labeled on the axis, we can go ahead and label it. So you can see it goes, this distance here is 30, and then it's 15. So half of pi over 2 will be pi over 4, and then a little bit to the left of that will be pi over 6. And that's what I'm doing, just labeling those. So at pi over 6, what is equal to 2? And then at 5 pi over 6, it's also equal to 2. So I'm just labeling 5 pi over 2. It's just before you get to 180. So that's what that graph looks like for cosecant between that interval. All right, looking at this other side. So I'm going to label 7 pi over 6. So just, you see, just past 180 is going to be 7 pi over 6. And then just before 360 is going to be 11 pi over 6. All right, and at both of those values, the y is negative 2. Y is negative 2. Okay, so my cosecant graph in that interval looks like this. This is a listening check. Put a box around number 4, question 4. All right, so let's go ahead and look at the range. Well, the range is the bottom to the top. Okay, so it goes from 1 to infinity, closed and open because infinity is never closed. And then from this interval, it goes from, the maximum is negative 1, and it goes from negative infinity to negative 1. And it's closed on negative 1 because it includes that number. So within those intervals, that's the range. Okay, so what is the period? So when does it start repeating is what we need to look at, right? So let's look at sine. This is what the sine looks like. Now, based on the pattern that we have just seen, my isotopes are always going to happen when sine is equal to 0. So let me go draw my isotopes in. And then to find your cosecant graph, all you do is you make a U within those isotopes. So when does this repeat? When does the pattern repeat? It goes, that's 1 period for sine, and it goes u then n, u then n, u then n. Okay, so 1 period also for cosecant will also be 2 pi. It is the same as sine. Okay, so let's take a look at some examples on transformations that you might have to do. And this will give you a hint. So you're going to graph 2 sine x without the labels. You need to find the amplitude. So basically, because we know how to find sine, once you do the shifts for the sine graphs, you can then graph the cosine. So that's what we're going to do. We're going to act like this question is sine and then graph cosecant. So what's the amplitude? The amplitude is 2. So it's going to have a height of 2 instead of a height of 1, right? This is a listening check. Make sure it has a height of 2 and a minimum of 2, because I'm going to label it wrong in just a second. All right, so this is my original graph. Now, what does the 1/2 x do? Well, let's find what the period is. It's 2 pi divided by b, which is going to give me, when you flip it, 4 pi. So the period is 4 pi. So 1 period of sine is usually what? 2 pi, right? But now it's going to double and become 4 pi. So it's going to be twice as long. So I'm going to just measure those same boxes. And so the first half of it, and I'm just going to put my quarters in as well. My first half of it is 2 boxes away. So now I'm going to multiply that by 2 because it's twice as much. And now my next one will be 4 boxes away. So what's 2 boxes now becomes 4 boxes. Okay. So that's what I'm going to repeat all the way around. So the n has been stretched to look like that. Now I'm going to do the bottom half. Okay, so it goes from 2 pi to 4 pi because it's been stretched times 2. If you count the boxes to the maximum, it's 1 box. And then you multiply by 2, it'll be 2 boxes, 1, 2. So that's where your new maximum is. And that's how you look. So your minimum would have been 3 boxes, then times 2 would be 6 boxes away. Then your final point was 4 boxes, times 2 would be 8 boxes away. So you can do it by boxes if this was confusing. Okay, so that's what I have now for 2 sine 1/2 x. Now what I'm going to do is draw my isotopes. So remember, every time it crosses the x-axis, that's where my isotopes are. So once you have my isotopes, all you have to do is make the opposite of what this current sine graph is. And you can keep going on as well. So that's what 2 cosecant 1/2 x looks like. You graph what 2 sine 1/2 x looks like, and then once you draw in your isotopes, you go ahead and flip it. So let's go do a more complicated question. But for this one, okay, so first of all, I made a mistake. It should be over 2 there, because when you write it in standard form and you take the 1/2 out, 3 over 4, taking 1/2 out will be 3 over 2. So make that correction. So it's going to be, again, taking 1/2 out, you divide by half, it's going to leave theta plus, and then 3/4 divided by half is 3/2. Okay, so what does this tell us? So we're going to use the rules instead of doing the amplitude in case that has been confusing you. So this one, what does this mean? It means a stretch, or rather a shrink in the y direction by a half, right? Because it's y and regular, it's going to do whatever you think it is. All right, what's the 1/2 here going to do? Remember, it was inside attached to the x or attached to the theta, and it's going to be opposite of what you think, right? So a fraction, you think it gets smaller, but because it's opposite, it's going to get bigger. So this is a stretch in the x direction by 2. Okay. Now you can calculate the period, just so that you don't have to think of it the opposite, which is 2 pi over b, which is a half. And when you simplify that, you're going to get 4 pi. So that makes sense, because 1 period is usually 2 pi, and now times it by 2, you get 4 pi. Okay, so you can think of that either way. The last one, what does that say? It's opposite of what you think. So you think it's going to go right, but really it's going left. 3 pi over 2 shift to the x direction. All right, so we're going to go ahead and graph that. Once you have all the rules written down, we're going to graph it. Okay, so you have to know what the graph looks like for sine. It goes from, in fours, it starts 2 pi, half of that is pi, half is pi over 2, and then 3/4 is 3 pi over 2. Okay, you have to know these values. It goes from -1 to +1. All right, so now we're going to go in order. We're going to do box number 1, which says we're going to start off with sine of theta. And then the very first thing we're going to do is we're going to shrink it by half. But remember, for sine, it goes from -1 to 1. So when you take those numbers and divide that by 2, instead of it going from -1 to 1, it's now going to go from -1/2 to +1/2. So go ahead and put those in. All right. Number 2, we're going to take the opposite and stretch it by 2. So we have 4 boxes makes a full period. So now instead of 4 boxes, it's going to be 8 boxes. Now because I'm going to shift the graph left, I'm going to move the y-axis because I'll need more space on the left-hand side. So I'm going to move the y-axis somewhere in the middle. Okay, then I'm going to, make some boxes, and I need at least 8 lines. So try and kind of separate it, make it equal, and then just keep half in it, and then we'll just work with what you have. All right, so it's 4 boxes for 1 period. Okay, so for 1 period after you multiply everything by 2, it'll be 8 boxes. Matter of fact, I'll just do it on the top one. So this is 2 boxes to get to pi. So 4 boxes will get you to the new pi, right? To where the end portion of your graph. It's 1 box to get to pi over 2. So the maximum. Now instead of it being 1 box, we're going to multiply that by 2. It'll be 2 boxes. Okay. All right. To get to where it intercepts the x-axis, it was 2 boxes. You multiply that by 2, it becomes 4 boxes. The minimum was 3 boxes. To get to the new one, you multiply by 2, it's 6 boxes. So this is what my new graph looks like. Okay, so go ahead and graph it in. This is a listening check. Put a box around notes. So go ahead and just copy down the notes. So we've done 1 and 2, and the last thing that we need to do is 3. Okay, the most important thing to remember about that stretch, by the way, is to do it from the origin. All right, so now we're going to move everything 3 pi over 2 to the left. Where's 3 pi over 2? Well, how many boxes is that? That's 3 boxes. Let's go ahead and put it in. 3 boxes, right? So moving every point 3 boxes to the left. So starting at the origin, 3 boxes to the left. I'm just going to put some labels in. And then go ahead and cut those in half because those are 2 boxes. Pi is 2 boxes according to my graph up there. So make sure you put, so that you don't get confused. All right, so we're going to start at the origin. And we're going to move 3 boxes to the left. 1, 2, 3. And that's my new origin. You're going to take a maximum, move 3 boxes to the left. So it starts at pi, so start at pi. 1, 2, 3. That's your new height. Then go to and I'm just going to draw those lines so I can keep them the same. It intersects as 2 pi, so start at 2 pi, then count 3 boxes to the left. My minimum starts at, and I'm just going to write this in, 3 pi, so start at 3 pi, and move 3 boxes to the left on the minimum, so on the bottom. All right, and then it intersects at 4 pi, move 3 boxes to the left. That's going to bring me just before 3 pi. So this is now after my shift, my graph looks like this. And of course you extend it in both directions. All right, now that I have that, I need my x-intercepts so that I can see what my isotopes are. All right, so because this right now I've graphed a half sine theta over 2 plus 3 pi over 4. Now I just need to make it cosecant. The only thing is different is you just need to put your isotopes in where it intersects the x-axis and then draw the opposite of sine. So that's what I'm going to do right now. I'm just going to transfer my boxes in. Okay, I'm going to copy the where the zeros are. I'm just going to put my isotopes. So there's an isotope right there. And obviously there's a pattern. So between every isotope is 4 boxes. So every 4 boxes, I'm just going to put an isotope. That way I don't have to keep figuring out what is what. All right. Then you can see just before the y, and remember it's a half. We changed it from +1 to a half. So at that point, it's going to be a u because it was already an n. And then from there to the next one, that's going to be an n because it was already a u. So you're just doing the opposite basically. And then follow the pattern. It goes up and then down. And then if I kept going, it would go up again, then down again. Okay, and that's basically how you graph the reciprocal. So you have to know how to graph the original in order to graph the reciprocal. Let's practice.